Okay. Just because we had so much supplemental, so I'm just gonna talk through what we went through, just in case anyone needs that. So we did this problem here where two charges, one here and one here and one here, were placed at these coordinates. So basically 7 centimeters on the X and 2 centimeters on the Y, 3 centimeters, my bad. So from there, we're asked to calculate the electric field. So we're going to use this E equation here, where K is constant, Q1 is your charge in coulombs. So we had to convert the microcoulombs into coulombs. And then your R is your distance in meters, so centimeters into meters. We plug those in for each one. I have the constant of K up there because I didn't feel like writing it in. So yeah, 40 and 7. And then that gives you these electrical fields. And then because you want to find the electric field at a point charge, which is right here, we did this equation here to kind of calculate for that field. And then in the end, we got 2.1 times 10 to the 8 newtons over centimeters. Sorry, coulombs. And then after that, we did an electron that's accelerated by an electric field. So we have our electron here. We have this Q, which is going to be a charge of an electron, which I didn't write. I have it here. Charge of an electron. And then it's going to accelerate through here and go through the little hole. And then it's asking for the speed that it leaves this hole. So we need to find acceleration first. We know that E is equal to force over Q. And then from that, it can go into force equals E over Q. And then you can remember that force is also equal to mass times acceleration. So you set them equal to each other. And isolate for A to get this equation here. From there, you plug things in. You were given the E, so you plug that in. You know the Q because it's the charge of an electron, which she should give you that. And then you have your mass also given here. So you plug that in, you find for acceleration. And then you plug it into one of our old friends from last year. It does say that from rest. It says accelerated from rest, so your V naught's going to be equal to 0. And then it says that there's 2 centimeters between the two plates. So that's why you have the 2 centimeters, which becomes 0.02 meters. Anyway, you plug that in and isolate for V final to get your answer. And then the third problem that we did had 2 point charges with different magnitudes. Well, same magnitude, different charges, basically. We also calculated the hypotenuse length here because we're looking at the distance from A to this point and the A to this point and B to that point and B to that point. We just calculate the hypotenuse using Pythagorean theorem. That's all. And we're using the voltage because that's an electric potential difference. So these are the two equations. We added the voltage from point 1 and voltage from point 2 according to point A. That's why I have the RA1 and A2. And then we just plugged it in from there. Don't forget that because it's microcoulombs, you need to convert to coulombs. Same things for, well, the meters are in meters, so you're good. Double check that you have the right, like this one's negative, this one's 0.5, because on this side, the negative charge is 0.5 meters away from the A. Let me get rid of some of these yellows. I did 0.5 from the A. And same thing for the 1. A is 3 centimeters from the 1, so there you go. Same thing for the B, it's just kind of the reverse, because for B, it's only 3 centimeters from the 2 and 5 centimeters from the 1. So you plug that in, you get very similar numbers, the only difference is this one's negative. And then because it asks for the difference, you're going to subtract the 2, which in the end gets you 9.6 times 10 to the 4, and then you just move the decimal over to get 96 times 10 to the 3, negative 96. So there's that one. And then we also noted that the difference between the force and the electric field is the force uses 2 charges because it's looking at the interaction between the 2 charges. And the electric field is just looking at 1 charge because it's looking at how that charge is exerting its electric field. Anyway, that's all. I hope you have a nice